Hello everyone, we will now see our next tutorial, that is basic many-to-one approach of creation of abstract model file. So in last tutorial we have seen one-to-one approach of creation of abstract model file. Now in this tutorial we will see many-to-one approach of creation of abstract model file. So let's start. You can see here, this is the general schematic of the classes. So you can see some classes here. For example, shell 2D is there, solid is there, maybe solid bed is there, solid mass is there. So these are the general classes which will help to cover some small cases. Again, you'll have to add the classes based on your requirement in order to cover all the practical cases. But this is the general schematic of the classes. And if we see here, this is the general schematic of the attribute. So we will be using attribute which is shown by the triangular shape for covering the small cases. So attributes will be specified either on the relation or on the class based on the requirement. So this is again the general schematic of the attribute. It will get updated, or you'll have to add the classes and you'll have to add the attribute based on your cases or based on your requirement. Let's now see the model, that is a box over box assembly. So this is the case. Let's say we want to evaluate this case, and the physics is like we want to apply the load at the top of this cube and we want to constrain the bottom face of this cube. So let's say we want to carry out two load steps. One is for gravity, one is the load applied here at the top. And for this case, if I now see the schematic of my classes, then out of all these classes, the classes which are highlighted, those are only applicable for this cube over cube assembly. So you can see here the gray out classes, they are not applicable to my assembly. Again, the classes and their relevant relation will not get applied for this cube assembly. Similarly, if I see the schematic of the attribute, then the classes which are not applicable, their relevant attributes will also not get applied for that cube over cube assembly. So this is how you have the general classes, you have the general attribute available, and whatever is applied to your cases, it will come into picture, and all other irrelevant classes and irrelevant attribute, those will not come into the picture. With this basic schematic, we'll just first see the simulation model and we will try to understand what exactly we are saying many to one approach of abstract model file creation. You can see here I have opened the many to one abstract model file. Now this abstract model file contains all the general classes, relation and the attributes which are applicable to your general small cases. So you can see here under meshing tab, we have the attribute related to meshing. Under solution strategy, we have the corresponding attributes. Problem definition and output tab contains the respective attribute as well. So this is the abstract model file which contains the general classes, relation and the attribute which will be applicable to your small general cases. We will now see how to use or how this abstract model file is applicable to our cube over cube model. Prior to that, just notice here there are a lot of classes available. Maybe we can see some contact bushing or the contact pin. These classes are present there and they are used somewhere here in the problem definition for contact pair attribute. But for our cube over cube model, these classes are not at all applicable. So we will see what happens when we actually link this abstract model file with our cube model. So for that, we'll create the simulation model. So everybody knows that for creating simulation model, we need to click on this icon, that is simulation model. After that, we'll just select the CAD model, that is 2-cube assembly, and then we will have our simulation model ready. So you can see here, this is our simulation model, and if I see here in this window, that is class window, then I can see the classes which are relevant to my this cube assembly. So in my abstract model file, there were a lot of classes like contact bushing or the contact pin, but those are not relevant here. That's why those classes are not present here. Similarly, the attributes which are applicable to this model, those are only getting transferred during simulation model creation. So this way we can create a general AMF or many to one AMF, and we can use it for our model. Now you can just verify all the details, whatever physics you want. For example, this load, you can just verify that if it is showing the correct geometrical entity here or not, maybe all the details like your subcase ID, your load magnitude. So all those details you can verify for all the attribute, and once done with that, you can just carry out your meshing and the export of your input data. So this way you can start with this many to one abstract model file, and you can just have your model, and if necessary you can just do some modification in that abstract model file, and you can just carry out your further steps. So this is related to 2-cube assembly or the box model. We will also see couple of models, and we'll understand how this single abstract model file is applicable to all the models. This is another example of coupling model. So you can see here, this is my coupling assembly, and it contains some parts like your left hub, right hub, some bottom plate, and a pin structure here, and the dummy cylinder representing my loading location. So physics would be, I want to constrain at the bottom face, I want to apply a load here at the center of the pin, and I also want to consider the gravity loading. So this is now another model, and if I see my schematic of classes, then you can see here, these are the classes which are relevant to my coupling model, and the classes which are grayed out, those are not applicable for this coupling model. Again, the relation corresponding to those classes which are not present will not get considered, and the relation which are present, or the classes which are present in my model, then the corresponding relation will also get considered for that model. Similarly, if I see my schematic of attribute, then the classes which are present in the model, then the attribute corresponding to those classes and the relation will get considered, whereas the classes which are not present, then the attribute specified with the help of those classes, those will not be considered. So this is the schematic of the schematic corresponding to my coupling model. Let's now quickly create the simulation model and see how we can use the same many to one abstract model file for this model as well. You can see here I have opened the same many to one abstract model file. So as I said earlier, this file contains all the general classes, relation, and the attribute covering the physics of small cases. Now we know that the classes present here, some of them will be applicable to the coupling model and some of them will not be applicable. So let's create the simulation model and see which are the classes which are applicable to the coupling model. For that, I'll click on this icon. After that, I'll just select my coupling model here, and with this, my simulation model will get created. So you can see here, this is my simulation model of coupling assembly. And if I see here now, then these are the classes which are relevant to my this coupling assembly. You can notice that a lot of other classes, those are not present because those are not applicable to this coupling model. Similarly, the attributes which are applicable to this assembly will be considered here in the simulation model. So likewise, we can have many to one abstract model file and we can use it for multiple models, and the classes and the attributes which are applicable to that model will be only considered during your simulation model. Now, once done with this, again, you can follow your usual steps like creation of mesh and the creation of input deck, and then you'll have your input deck or the input file available corresponding to the particular assembly. So this is about the coupling assembly. Till now, we have seen that we use many to one abstract model file, and we used it with the two different assemblies, that is cube assembly and coupling assembly. And still that same abstract model file is applicable to my both the models. The classes and the relation and the attributes relevant to those models will be considered automatically while creation of the simulation model. Let's now see a couple of more examples so that we can have the understanding of how this one abstract model file can be used across multiple models. Let's now see one more example. So this is shell to solid coupling model, and you can see this is my solid part and this one is my shell part. So from physics point of view, I'll be considering this end and I'll be applying the load on this edge. Also, I'll be considering a gravity loading as well. And if I see the schematic of my classes for this model, then you can see that the classes which are relevant for this model will be considered, and the classes which are grayed out, those are not applicable to my shell to solid coupling model. Same applies to my attribute also. So if I see the schematic of attribute, then the classes which are applicable to my model, then the corresponding attribute specified on the classes of the relation will be considered, and the classes which are not applicable, so their corresponding attribute will not be considered. So this is about the schematic of shell to solid coupling model. Now let's use the same many to an abstract model file and create the simulation model for this shell to solid coupling model. You can see here I have opened the same many to one abstract model file here, and we'll now see how this same abstract model file is applicable to my shell to solid coupling model as well. So for that, I'll just create a simulation model here. I'll just select my shell to solid coupling assembly here, and my simulation model will get ready. So you can see here, this is my simulation model. Now it contains the classes which are relevant to my shell to solid coupling assembly. Also, it contains the attribute which are relevant to this assembly. So this way you can create or you can use this many to one abstract model file, and if needed you can just add the classes or the attribute based on your case, and same abstract model file you can use for the multiple models. We will now see one more last example, and after that we will see how exactly this approach differs from the one-to-one approach. This one is another example, that is L plate model. So you can see here, this is my L plate, and we have a mass here which is connected to this L plate. So we will be creating a mass element here, and we will be distributing it with the help of distributing element on this L plate. So we'll be constraining the bottom side of this plate and the load will be applied here. So if I see the schematic of my classes, then you can see here the classes which are applicable to this model, those are highlighted, whereas the classes which are not applicable, those are shown or those are grayed out. Same applies to the attribute as well. So if I see the schematic of my attribute, then the classes which are applicable, their corresponding attribute will be considered or will be applicable to this model. The classes which are not applicable, their corresponding attribute will also not considered or will not be applicable to this model. So this is about the schematic. Let's see the simulation model for this LPLET. You can see here I have opened the same many-to-one abstract model file, and if I create the simulation model with this LPLET model, then you can see that in the simulation model the relevant classes are only considered. Same applies to the attributes. So the attribute which are applicable to this model or this assembly will only be considered. So this is what the many to one approach is. So we created a single abstract model file containing some classes and the attributes capturing the physics of some of the problems, and we could use that abstract model files with those respective CAD models, and we could generate the input tag corresponding to those models. So this way you can keep on adding the classes in this abstract model file based on your requirement. You can keep on adding the attribute, and this same abstract model file you can use for your multiple models. So this is what we call it as many to one approach of abstract model file creation. We will now see what exactly the major difference is between one to one approach and many to one approach. You can see here I have opened the CAD model from the earlier tutorial, that is one-to-one approach. So you must be remembering that one-to-one approach means we are assigning one class to one component. So we had seen the limitation of this approach, that we cannot add the physics or we cannot consider the simulation physics efficiently with the help of single class assigned to single part. So you must be remembering that we wanted to specify a contact pair attribute here, but because of this limitation, we could not do that. There is an alternative, but the alternative is to change the class or to assign different classes to different parts, and that in turn will increase the number of attributes. So one-to-one approach is not the effective way of using abstract modeling technique. Now, the limitation of one-to-one approach is not there when we are going with many-to-one approach. Maybe I'll quickly show you the CAD model which we used for the many-to-one approach. So you can see here, this is the CAD model which we use for many-to-one approach, and if you see here the tagging, then we have assigned multiple classes to each part. So in one-to-one approach, we just assigned a single class to single component, whereas in this approach, we are assigning multiple classes to single part. So because of the multiple classes, we can just add the simulation physics as per our requirement. Also, if we follow the standard nomenclature or the standard tagging practices, then we can have many to one abstract model file, and we can use that abstract model file against the multiple models. So what you guys can do is you can just take this many to one abstract model file, you can just add the classes or the attribute as per your requirement, and you can use that file for your problem or for your case. So this way, with one abstract model file, you can just create the multiple input text corresponding to multiple cases. So this is about many to one approach, and it is recommended to use this many to one approach over your one to one approach, because that will help you to standardize your process, as well as that will help you to create one abstract model file which will capture the knowledge of your simulation physics. So with this, we are done with this tutorial. If you guys are having any question or the queries, then please feel free to contact at support@novosnexus.com and we'll get back to you accordingly. We will now meet in the next tutorial. Till then, have a good day. Bye.